Hello everyone. My speech will be on Russian to not frustrate you by my English. So let's start my talk about infrastructure automation with Chef, Ansible, and Docker. It's a small amount of information about me. I'm web and mobile developer, most of all, also administrator of Linux stuff. I have some open source projects, 2 books, open source books about cooking infrastructure by Chef, and books on Russian about PostgreSQL. And also leading RubyPod podcast, it's about Ruby and web. So first of all, what is infrastructure? All stuff which help to us manage our application. It's web servers, databases, servers, maybe some virtualization. It's called infrastructure. And intercommunication of these components also going to infrastructure. Infrastructure should be highly performant, reliable, secure. That's why it's our main goal to do all this stuff and do effective as possible. So what is Devops? Devops, it's like communication and collaboration of dev guys and ops guys. In some company I see like anti-DevOps pattern, like DevOps guys develop application, then archive it and send by email to ops to deploy this on some servers. It was very bad stuff. That's why DevOps is one of the way to do better deployment process, communication process, and also DevOps is mainly CAMS. CAMS, it's 4 major stuff. It's culture. So ops, it doesn't possible like you said, okay, we will hire DevOps guy and we will have DevOps. It will be perfect. It's not possible. We need DevOps is culture. It's like Scrum, something like that. Culture is first of all, you should have DevOps culture. If you will not have culture, you can forget about DevOps stuff and all this. Automation is second, of course, because DevOps is the main stuff for automation. Third one is measurement. You should measure to improve yourself. You should understand does this stuff help or not. And sharing. You should share your collaboration. It's main stuff in which even our company is bad. To share your stuff, not only between inside your, for example, team, but also inside company, inside all community. Without this, it will be problem and cycle will be not closed and culture will be also not so good. So DevOps is not a plan, it's like reaction of some process. It's not a product. Benefit of DevOps. Many developers, like if they think about benefit, they only think about own benefits, not about business benefits. They just come to us and say, okay, we will use React, Docker, and all this stuff. And they say, okay, what benefit for business? And they say, just for us it will be cool. So should be technical benefit for all this stuff and business benefit. Without business benefit you can forget about this stuff. Technical benefits is continuous software delivery for us because we continuously deliver our stuff, see how it works. It's less complex problem fix because we can because we continuously deliver step by step small chunks of features, we can already see like what we have regressions, why we have these regressions, what small amount of feature influence on this stuff. It's because I see commands which, for example, working in some branch almost 1 month and then deliver and try to understand what's going on after this delivering, because they have huge amount of feature inside this deliver and don't understand which feature influence on this stuff. And of course, faster resolution of problems. For business, of course, it's fast delivery of features, because it's main what want business, and C, it's fully like it's visibility for business you're processing, because for example if you several months developing something and business doesn't see progress, it's begin frustration like, guys, what are you doing? I don't see anything. It's one of the main point. Also more stable environment because it's predictive. You also testing this environment. It's one of the main stuff of DevOps. And more available time to add value to product, not fix some problems, not hero mode like, okay, we have down production and I will fix this. This is two good books if you want to understand the main concepts of DevOps. It's a DevOps cookbook, or very old book, and also a new one called Phoenix Project. It's novels, how to DevOps help business. So let's begin our automation. So DevOps, first of all, it's automation. We want to automate all this stuff. I'm also a very lazy developer. I want to automate everything if it's possible. So configuration management software. We have huge amount of, for today, configuration management software. It's Chef, Puppet, Ansible, SaltStack, CF Engine, Juju, Fabric, maybe someone knows, and many, many others. It's a very huge amount. But I will talk today about Chef, Ansible, and a little about Docker. So Chef. For Chef exists two main configurations, Chef Solo and Chef Server. Also exists Chef Metal and another stuff, but these two main, which we will consider. Chef Solo is very simple. It's run locally, push mode, like you're doing with Capistrano, but instead of Capistrano, it's fully copy-paste itself in server and begin running on the server. Simple for beginning and small amount of nodes. For example, if you have a project with one node, maybe Chef Solo will be best for you. Chef Server is a little compatible because it's server-client model. You communicate with server, and server communicate with nodes. It's pull model, like nodes go to server and ask what I should do, and it do by server configuration. So instead to communicate with each node directly, you communicate with server and provide information for it. Good for big amount of nodes. We have several hundreds nodes inside Chef server, and it works perfectly without any problems. Also good stuff that node can store data about itself, like, for example, each node, each Chef client collect information about node, like IP address, CPU, memory, and another stuff, and you can reuse this information to another nodes. For example, we have like proxy server, and this proxy server have configuration depends on how many web nodes we have. So if we automatically add new web node, it automatically change proxy configuration and reload it. If we remove, for example, this web node or several, proxy configuration automatically will be updated because it collects information from these all web nodes from Chef server. This is also good stuff like search indexes, and of course centralized API to integrate with many stuff. This is how it looks like Chef server. So workstation is your computer in most cases. You work with Chef server by Knife utility. You just communicate and say what's going on, upload this stuff, how it's not working. Of course, you store all information, your environments, roles, database in Chef repo. And Chef server have all this information and provide this information to Chef clients. So Chef clients like only provide high attributes and pull what should it done. For example, you provide information like web nodes should have Nginx and another stuff, and Chef client will do at least until it will be the same. Like if I should have Nginx 1.8.0, it will install if not exist. If it exists, it will just ignore this and continue working. Main benefits of Chef, of course. First of all, it's Ruby DSL. Ruby is perfect language, and yesterday, for example, many say like we only use Ruby and Rails for web development. By half of my working hour, working with Ruby, and it's not web development, it's DevOps. Good dependency system. It's have Berg shelf, also Librarian shelf, but Librarian shelf maybe too old and not too good for today, but it still exists. 2,000 vendor cookbooks. It's also very good cookbooks because it provides huge amount possibilities. It have good testing inside these cookbooks. Also Chef have good team workflow. You can, like, if you have huge team for several teams with ops, they can split the workflow and don't have problems with merge their features. Support Windows, so-so. At least how Windows support Ruby. And huge amount of testing tools. It's one of the main stuff because Chef use Ruby inside, and because it use Ruby as it take all infrastructure of Ruby, and of course have huge amount of testing tools. So it have Chef spec, server spec, bets, test kitchen to test your cookbooks on different servers and type of server. Chef Zero, if you need, like, you have cookbook which should work like with real Chef server, but of course we not write tests which work with real external services. We can mock this by Chef Zero. And for example, some our teams to create locally like production environment can use Chef Zero instead to working with real Chef server. Minitest, which also help to us test on real production environment. After all our recipes and cookbooks, he can run tests and check like this daemon works and running, like this port is open, this page answered by this content. It's also very good for us. FXHI, for example, to mock OHI special stuff, which provide, as I said, API address, CPU, memory, and for example, you need test all this stuff, how it's work inside your cookbook. You can mock this by this stuff. Cucumber and Foodristic. Foodristic is just like ESLint, JS Hint for JS or Rubocops for Ruby. It's something like this for Chef cookbooks. But of course, it has also disadvantages. First of all, you need to know Ruby. For many developers, not this one, but for many ops, no new language, it's crazy. Need to install Chef clients on nodes. So you need install Chef client because Chef client doing main work, and this is maybe main disadvantage because sometimes also Chef client can be broken. Inside it you use Ruby gems, and this Ruby gem sandbox can be broken. In this case, some cookbooks, for example, PostgreSQL couldn't install PG gem in normal way, and this should be fixed. Sometimes just roll back to previous version. It's a little crazy. Different team with different approaches, because many teams, Chef provides several possibilities to work with it, like you can store rows in JSON format or in Ruby format, and then different team merge, they see one have in JSON format, another in Ruby, and then should select and migrate to one format. It's also maybe a little problem. Documentation is not perfect. Chef have wiki, but in this wiki more see like what is raw, what is Chef, but doesn't have huge amount of information how to get started and what best approach for this. And of course, too many tools and options. Sometimes it's also a problem like it's you go to do MVC to select best JavaScript framework, and you understand it doesn't help you. You see huge amount of stuff, huge amount of implementation, and don't understand what to use. The same here, huge amount of tools, and you don't know what best for you and how to use it. So this is my book. It's free or open source and should help to you to learn and run your Chef, also for testing, because one of the main stuff for Chef is testing, because instead only running the cookbooks, receives all stuff on real servers, and only after this understand all was good or not, you can test this stuff, like real your Ruby application or Rails application. So next one, Ansible. Ansible is run locally like Chef Solo, so you just push model. So it's also upload itself in Node and begin running. It's clientless, only need Python, and in most Unix systems we have Python by default. It's have YAML configuration, so it's like command line infrastructure. Instead, then Chef have code as infrastructure, you coding it. In this case, you have like commands. Like it's very, administrator very like this approach, because you just type command, please install this one, please run this one, it's better for them, and no need to know coding, you just need little learn YAML configuration and that's all. Huge community, and Ansible Tower for little automation. It's like web interface for some cron jobs to run Ansible. For Ansible also exists approach like for chef server, like poo. But in this case, you should install Ansible on each machine, and this is not standard approach. That's why I don't talk about it here. This is how it looks like Ansible. So this all big sphere is your machine, and you just working on local machine and pull on all host your configuration. Like you have inventory files and another stuff, and you just install what you need, run some services and another stuff. Disadvantages. First of all, it's how we had in our teams, bad teams workflow. Huge amount of problem with merging. Commons try to use working in the same YAML configuration. It's very hard to split all this stuff. Also, for example, you don't know which part of these changes was already applied on nodes, which doesn't. And each time you should run. Small flexibility of coding. It has cycles, it have conditions, it have small amount of variables, and that's all. Instead, like I have in Ruby, I have huge amount of flexibility. I have clear Ruby and can do anything what I want. Here it's only small amount. If you need coding, you go deeper in Python code and all this stuff, but in this case you should also learn API of Ansible. Poor development testing. Because Ansible working on top of Python, in this case, it gets infrastructure from Python. And as I see, a huge amount of Python developers, top of them maybe write unit tests, it's maximum. That's all. No huge amount of testing tools or even testing approaches. Even inside in Ansible documentation, they doesn't have like best approaches for testing. They just, okay, you can use dry run to see how it's going on, and maybe Vagrant, that's all. Limited support for Windows. It's from 1.7 version. You can work on Windows, but you need to install VRM and small amount of rows support all this stuff. So if you want to use Ansible, maybe. But in most cases, all these tools doesn't work good for on Windows. This is good book which write my coworkers. It's Lauren Hochstein. We together work on some product which work deeply with Ansible, and after this he write this book. It's not free, of course, because it's not mine. That's why if you want to learn more about Ansible, you can try and buy this book. Docker. Okay, because right now everyone says Docker, Docker, we will use Docker everywhere. It's immutable infrastructure, microservices, all this stuff. So Docker is operational system level with virtualization. It's C groups, namespaces, and API to control this stuff. So it's nothing maybe special, just what good provide for us Docker, it's API to control this stuff. It's use lib container. Written inside this stuff, it's written by Docker team. Also can support libvirt, Alexey, and systemd and spawn. So multiple containers, but they all share the same kernel. Simple configuration and distribution. Right now, Docker supports huge amount of platforms and community like AWS, Google, Microsoft, IBM. So like if you will create container, and we will say like, I provide for you a Docker container, everyone will understand how to use it and how to start running it. So this is how it looks like Docker. So instead of virtual machines, which use hypervisor, which run guest OS, and in this case you have fully virtualized machine, which you can do anything and it will not influence on host machine. In this case, Docker just run on host machine, so they use the same kernel or the same stuff, and just use some directories, namespaces, all this stuff. But this provides more faster creating of these containers, because for guest OS you should load like virtually real OS instead of Docker. Just provide this all small stuff. So this is what I heard in mostly, like Docker all the things. We should Dockerize all. and mostly say like we need microservices. Microservices is Docker and microservices. Yeah, it's one of the main trends. Like, for example, we have rapid application development with our Rails stuff. After this, we begin era of app-optimized clouds with Docker containers, and we were going to microservices architecture right now. And we will back to rapid infrastructure, rapid app development. Maybe it will be not Rails, something else. So about microservices. Many teams saying like microservices is safe. It's save our time, save our team. It will be best for us because, for example, they fails with monolithic application. But as I said, for many teams, if you can't build a monolithic application, what make you think microservices are the answer? It's very good notes about Simon Brown in his book about microservices, which explain like problem solved not by microservices, it's not silver bullet. For example, Akira Matsuda on his Ruby on Alice talk talked about recipe for world's largest monolithic applications. He used huge amount of servers, almost 300 servers in the peak, a huge amount of models, more than 100 models, huge amount of controllers, test environment running on Mac machine almost 5 hours. But in all this stuff, as you understand, it have responsive API less than 80 milliseconds, and render was less than 200 milliseconds. So it was very good architect application. And in this talk, he provides like how they do their stuff, how they deploy on this huge amount of servers, because not Ansible, not Capistrano, not Chef, any of this stuff doesn't help, and they use another system to deploy because SSH is too slow for all this stuff. So first of all, if they're thinking about microservices, first of all, we should understand that microservices is part of service which we can deploy and will influence on other. Because I go into another teams and they say, we have microservices. Okay, show me. And they have API and huge amount of stuff which working directly with this API. If I shut down this API, nothing works. And I said, it's not microservices, it's just monolithic, which you just split to some parts, but it doesn't microservices. Microservices should be fully independent and only maybe communicate each with other. So also about Docker. Many try to use Docker to create own paths, but Docker is just like hammer, and I give you hammer and say, okay, build me a building. And you say, okay, hammer good, but it's not good enough. And of course, you also should use some EAS, some like AWS, bare metal, or something like this. You should use some orchestration stuff, like Kubernetes or Cloudify. You should use some paths, also additional system which will control orchestration, and of course, Docker. So if you go into Docker and try to build your own path, you see something like this picture. Like, oh, I go into Docker, and I say, okay, here you are. Because, for example, if you need to set up Docker, set up system in which will run Docker and your path, you still need configuration management system. And in this case, you still need Chef, Ansible, Salt Stack, or something like this. If you need orchestration system, you need service discovery system, you need some operation system. For example, we use CoreOS with Fleet, of course, and ECD. And on top of this also was MesoS, Marathon, and you begin adding all this system. It's like huge Titanic in some day which can fail. And of course, for today, Docker provides for us more cheaper. Most providers by Docker make our clouds more cheaper, and in some time like AWS and another stuff provide more cheaper and cheaper for us environment. But creating own paths is hard stuff. For example, Russian provider Cloud Mouse show this good example. It's twice lose fully own cloud and closed. Because it doesn't need only create this. You also should understand how to backup all this stuff, how to manage all this stuff. It's also a huge amount of work. Set up this, it's small amount of problem which you have. So Docker use cases. First of all, create own path. It's possible, but it's hard, and you should understand this. Second, software distribution. It's very good stuff. Before this, for example, if you want to distribute some Rails application, we switch to JRuby, pack this Rails application into some jar or var archive and provide to customers. It was not so good system, and also about immunization and some sidekick or another stuff. We should think how we will do this. In this case, we have huge README how to set up our application. Right now, we just provide Docker container and run it. That's all. It will work. Many system open source use this already. For example, Discourse just distribute Docker container and said we officially distribute on the it, and that's all. Also, fast sandbox environment. It can be good for CIs. If you need user-defined scripts run inside it, custom workers, build systems. For example, you provide some system which build dep packages or some another yum packages. You can use like create sandbox, build it, and clean up it, and that's all. And of course, the debugging capabilities. It's avoiding to it works on my machine. Syndromes, like because I see some problems, like one team have one Node.js version, another Node.js version. They don't know about this. One have problems to create application, another no. In this case, you have like shared environment. You provide this environment and said, in this environment, this doesn't work, and that's all. So, of course, disadvantages. First of all, Docker isn't enough for building paths. You need huge amount of additional system if you want to build Docker on top of Docker your path system. It's configuration management tool, service discovery, and all another tool. Non-root operation inside Docker container. We don't try this. We have some system which also like paths, which provides slave databases. And to not provide a root operation, it was crazy. We have Docker, which create container, and inside this container we create another Docker, which create another containers to provide non-root operation for users. It was a little crazy. But it's, for example, in many CIs, you can see like if you need non-root operation, you use like Docker container. If you need to install something, then provide clear virtualization. Not good and linking across separate servers or VMs. Inside one server on VM, very good stuff to link in between containers. But if you begin working with huge amount of distributed servers, it's not very good with Docker. You should use additional stuff which will also work with network latency and another stuff between Docker containers. And also not good for isolating with Linux containers, between Linux containers, because they use the same kernel, the same stuff. If you need different Linux kernels and different stuff, you should switch back to standard virtualizations. So, summary for my talk. Devops isn't tool, it's process. First of all, Chef, it's Ruby code to infrastructure that's good for you, for example, but it's also have some disadvantages. Ansible, it's common to infrastructure, client-less architecture. For example, we use Ansible to cook our Docker containers because no need to install inside Docker something. Of course, exists Chef container stuff, but we no need to manage Chef container stuff. Docker, it's good for development and distribution of your software, and measure twice and cut once. Because if you select Docker, you should understand and remember all this picture, because you should deal with all this stuff. Not all, but you should select which one stuff you will use. In this case, you will deal with bugs and problems of this stuff too. And that's all. Thank you. Questions?
Okay, anybody has questions? Okay, let's go.
Даже неудобно. Доброе утро. Если позволите, вопрос на русском. Прежде всего, спасибо за столь прекрасный русский. Я хотел бы уточнить. Все нормально. Что делать, если у нас есть разбитая инфраструктура, которая отличается по бэкэнду и фронтенду, и она обслуживает разных клиентов? В этом случае каков будет наиболее оптимальный путь для использования инфраструктуры Chief? Есть какая-нибудь tree-like infrastructure?
You mean like one backend, one frontend,
yes.
They different clients?
Absolutely.
It just you can use one row like backend row, front-end role, and that's all. And one Docker server can also work with both environment. It like will be different roles, and then cook in different way this one, and in different way this one. It's not a problem.
Имеется в виду рецептура, recipes на...
Recipes can be recipe can be different, fully different. Even cookbooks fully different. It will be maybe have shared cookbooks, but you upload all this in one chef server, and like part of these cookbooks used on this server, part of this on another server. It's not a problem.
It could be scripted.
Yes.
Thank you.
Hi, what do you prefer for infrastructure automation, Chief or Ansible, and why?
Of course, Chief, because testing. Because I can also work by BDD, TDD. I can test the environment before going on real staging or production. Also because I like to coding. I don't like command to infrastructure. But as I said, for example, Ansible have some benefits like cooking containers or something like this. No need to install and deal with clients, invalid clients, chef clients. So I prefer chef. But also, for example, because chef have built-in copy-paste of Capistrano recipe for deploy, like fully stuff, and I can also deploy by chef. For Ansible, I should write own stuff or use some vendor roles for this. But I prefer chef, but Ansible also good. If command, for example, team already use Ansible.
You usually use Capistrano for deployment Rails application?
It depends. It depends from project. Usually for small project Capistrano, for some other projects Chef deploy, make deploy of this stuff. Some projects use Serve, which, for example, automatically deploy on all servers because we provide command on Serve, and Serve will deploy from Taubar or some archives, some releases. But it's a little harder system, but it's good if you have more than 100 servers, because SSH will slow for every system, and you will just okay, no SSH, we should use something else. And you use some torrent systems to deploy, a torrent-like client system, or you use Serve for orchestration, all this stuff.
Hi. Why I have to cook containers with Ansible if I can use Dockerfile for this?
Because documentation. First of all this orchestration stuff, Chef, Ansible, and other stuff, it's documentation for our environment. Of course, we can share this old Dockerfile inside all this stuff. But for example, I need things like I need apt-get install or yum install for different all this stuff. But instead I just use Ansible, which will have check conditions. If I working on CentOS, I install in this way. If I working on Ubuntu or something, Debian systems, I will install in this way. And I no need to write these conditions on thinking about this inside Dockerfile. And in this case, also Devops team looking inside Ansible and understand what's going on and how we cook this container.
Thank you.
In many cases, your application requires some credentials to access third-party services and APIs. And I would like to ask, where do you recommend to store these credentials? Because usually you don't want to store it in your source files or recipes.
We use Databox, and we use encrypted Databox. So in this case, we have symmetric keys, which we only share between team, and Databox store inside Chef repo, but it's like mass of encrypted information, and only with this key it can decrypt this information. We use 2 megabytes of key. It's huge enough to store and share this information. And in this case, we don't scare about this because it's fully encrypted, and that's all.
Thanks.
Because I'm really new to Chef, and maybe I've tried it a couple of times, can you describe what do you mean by testing Chef recipes or cookbooks?
I mean, for example, if you write some Chef recipes, like for example, please install for me Nginx, this version, it should be with some configuration and another stuff. In this case, I can run like AirSpec style testing, which will say like, Nginx should be installed in this type of version. It should be running, it should be demonized, and I write all this by respect style, like it should be running, it should be demonized, it should have configuration these lines of codes. In this case, it first testing, and exists second like test kitchen. First one, it just check how its will works. Another one, it will up in Vagrant or Docker your environment, cook it, and after this run your test inside this environment and checking it's real working, like 80 ports or 443 is opened and it should available. It provide for right now for testing environment some information by this port. If it's not, it's fail and you get error and you can debug because for example, as I said, in Ansible, it's very hard to do this. You can just manually do some stuff. But here I can work in by BDD or TDD, like first run test, it's failed, and I begin reading cookbooks, recipes, and another stuff. That's why I like, for example, working workflow. But of course, it's not like from Chef. It's because Chef use Ruby, and all this stuff comes from Ruby. Because if I think it's Ansible will select Ruby, it will be the same benefits. But Ansible use Python.
Thanks.
I think that's all, okay?
Yes.